Hello, this is Mrs. Rodolfi, and I'm going to go over the Unit 4A study guide. So this first page, it starts off with the exponent rules. And I would definitely recommend, grab mine, using this sheet that I gave you as a reference to help you the properties of exponents as you're studying for this test. And I would definitely write any of these down on your 3x5 note card to use on the test. So simplify k squared times m to the fourth power times k cubed. So we want to add exponents that have the same base. So if you notice, we have a same base with k squared and k cubed. So we can add those exponents of 2 and 3. And then m to the fourth would stay the same. So adding those, 2 plus 3 is 5, so it'd be k to the fifth power times m to the fourth power, and that's our answer. Number 2, now we have one that is a quotient of powers. It has a fraction which is division. So this shows us that we are going to subtract our exponents that have the same base. We also need to divide the coefficients, the numbers in front. So first do 36 divided by 4 equals 9. Then we have k to the 8th power, and then under it on the denominator is k to the 3rd power. So I'm going to subtract 3. Then we have the same exponents of m, so 5 halves minus 1 half. Simplify, 9 stays the same. 8 minus 3 is 5, k to the fifth power, and then 5 halves minus 1 half, that equals 4 halves, and then we can simplify that further. 4 divided by 2 is 2, so m to the second power, or m squared. Number 3, m times n to the negative fourth power. So in order to make it a positive exponent, we need to put n to the negative fourth power under 1. So m would stay the same, and then remember it's like multiplication. It'd be, so I saw a lot of students writing it like this way on the last quiz, 1 over n to the fourth, and then times n. But the way, and this is correct, but the way you'll see it on the test is m over n to the fourth. So just, think of m as m over 1, multiply across. M times 1 is m, 1 times n to the fourth is n to the fourth. So you'll see it like this if it's on the test. Number 4, now we have parentheses, k squared times m to the 8th to the third power times k to the negative 3 times n to the 0. So when we see this exponent on the outside of the parentheses, we want to multiply it or kind of distribute it by all of the exponents inside. So we would do k to the second power times 3 times m to the 8th power times 3. And then we'll just leave the terms on the outside the same for now. All right, k to the, and then 2 times 3 is k to the 6th power. And then times m to the, I'm thinking addition right now, 24th, 8 times 3. And then we need to simplify this further. We have our same bases of k here. Now the rule is I got rid of the parentheses. Now I just add the exponents. So 6 plus negative 3 is 3, k to the third power, times m to the 24th. n to the 0, this equals 1. So I don't even need to write it, because if I just put a 1 on the end here, that keeps this the same. Anything multiplied by 1 is the same. So that's our answer. Number 5, n to the 0 power. Anything to the 0 power equals 1. That is our answer. Number 6, k divided by m to the 8th power. Again, if you see this exponent on the outside of the parentheses, we need to distribute it to both the numerator and the denominator. So this becomes k to the 8th power over m to the 8th power. They are not like bases, we can't combine them, so that's our answer. Number 7, show how each of the following expressions result in a rational product. So remember, a rational product is a number that can be represented as a fraction. It's whole numbers as well, because they can be represented as fractions. It can be a repeating decimal, because some fractions are repeating decimals, like 1/3 is 0.33333. And then if it's so let's say you plug it into the calculator and you get a non-repeating, non-terminating decimal, that's irrational. So we don't want that. So what I would do is I would plug these into the calculator and check. If you're struggling with this, like do the square root. So here, let's rewrite it over here. So the square root of 2 times the square root of 8. So we're multiplying these by the square root of 2 to see if it equals a rational number. So test it on your calculator. Square root of 2, and then use the right arrow to get out of under the square root, times, remember, second x squared is the square root, and then the square root of 8. That gives us a rational number. So, just to break it down without using the calculator, we would multiply the numbers under the radical symbol. 2 times 8 is 16, the square root of 16. And then again, use your other sheet that I gave you. This one. And then the square root of 16 is 4. So you, of course, can't have these graphic organizers on the test, so use your calculator to help you. Then let's see if the next one will. So square root of 2 times the square root of 32. And let's try it in the calculator. Second x squared 2, and use your right arrow, times second x squared 32 equals 8. And to break that down, 2 times 32 is 64, square root of 64 equals 8. Last one, square root of 2 times the square root of 2. Try it on your calculator. Square root of 2, the square root of 2 equals 2. Remember, if we have the square root of the same number times the square root of that same number, it cancels out the square roots, because 2 times 2 is 4, square root of 4 equals 2. So these are all rational. Whole numbers, fractions are rational, as well as repeating decimals. Repeating and terminating decimals, because, for example, 3/4 equals 0.75. So that's a terminating decimal because it ends. It doesn't go forever. 8, show how each of the following expressions will result in a rational sum. So same thing here with rational, but now sum, we're adding. So the square root of 36 plus the square root of 81. So again, you can use your calculator, or you can just break this down. The square root of 36 equals 6. The square root of 81 equals 9. 6 plus 9 is 15. Square root of 36 plus 7. Again, the square root of 36 equals 6, and then plus 7 is 13. Square root of 36 plus the square root of 36. We then can simplify both these as 6 plus 6 equals 12. Number 9, now we have some subtraction and addition with radicals. For these types of problems, you can only combine like terms that have the same radicand. And the radicand is the number or variable under the radical symbol. So I see right away that we have, these have k, so these are like terms. And then these have m, so these are like terms. I also like to highlight the sign in front of them, the like terms, because that's what operation you'll use. So if we have 2 square root of k plus the square root of k, remember if it's just the square root of k, that's a 1 because there's one of those. So add the numbers in front, add the coefficients. So 2 plus 1 is 3, and then we keep the square root of k the same. Then we have negative 4 square root m plus 5 square root m. So again, look at those numbers in front. Negative 4 plus 5 is 1. And then you can write 1 square root m or just square root m is what you would see on the options on the test. And that's as far as we can simplify it. Next page, number 10. Now we're multiplying with radicals. When you're multiplying, you multiply the number in front, the coefficient. 2 times 5 is 10. Then we multiply the radicands. 10 times 40 is 400. The square root of 400 is a perfect square. And remember, use your calculator to test. Square root of 400 equals 20. So 10 times 20, because remember, when they're right next to each other, this is like multiplication. And 10 times 20 is 200. That is our answer. Division with radicals. You're going to divide the terms first. 54 divided by 2 is the square root of 27. Then we can break this up further. Using your perfect squares list, and if you want to write these on your note card, that might be a good idea if you need that. So 27, I know that the perfect square of 9 goes into 27. So I'm going to rewrite it as the square root of 9 times the square root of 3. This is an equivalent expression. Then I can break it down further. The square root of 9 equals 3. So I would take that out of the radical. And then the square root of 3 is irrational. I have to keep that under the radical. This is our final answer. All right, one more radical. Simplify 9 times the square root of 45m squared over 3 times the square root of 5. So again, first divide, because fractions mean division. First divide the numbers in front, the coefficients. 9 divided by 3 equals 3. Then under the radical, we can divide 45 divided by 5, which is 9. And then we still have m squared. Break this down further. So the square root of 9 is 3. The square root of m squared is m. So if I have the 3 on the outside still, then the square root of 9 equals 3. And then the square root of m is m. So I take those out, simplify it further. 3 times 3 is 9. This equals 9m. Number 13, tell whether each sequence below is arithmetic, geometric, or neither. If it is arithmetic, identify the common difference. If it is geometric, identify the common ratio. So again, first try it on your calculator. So like this one, look at like the patterns. This one goes from 24, 4, 2/3, 1/9. If this is geometric or arithmetic, it's looking geometric because it's changing more drastically and looks kind of exponential. So if you're not, if it's hard for you to tell though, do both types of checking. So first, like if I think it's geometric, I'm going to divide. I'm going to take 2 consecutive terms, so like 24 and 4, and I'm going to divide. 4 divided by 24. Now it's going to give me a decimal, so I'm going to put it in fraction mode, hit that green alpha and the button to the right, and I'm going to do 4 over 24, so that it'll keep my answer in a fraction. 1/6. Then I'm going to try 2 other terms, so like 1/9 and 2/3. So 1/9, and I'm going to divide it by the previous term, 2/3. 1/6. So that's geometric. Now, let's say you subtracted first. Remember, to see if it's arithmetic, you would subtract the consecutive terms, taking the second minus the first. So 4 minus 24 is negative 20. But I can already tell right away 4 minus 20 is not 2/3. But if you need to test it, 2/3 minus 4, that's negative 10/3. So it's not a constant difference. So it is geometric with the common ratio of 1/6. So R equals 1/6. Then we have the next one, 1, 4, 9, 16, 25. That one, it looks more arithmetic, but also I'm feeling like it's adding more and more each time. So let's test it to make sure. Figure this out. All right, so again, take two consecutive terms, 1 and 4. Take the second 4 minus 1, that's 3. Then choose two other consecutive terms, so 25 and 16. 25 minus 16, 9. That is not a common difference. Let's just make sure it's not geometric, so we would divide 4 divided by 1, and then take another two consecutive terms, 16 divided by 9. That is not a common ratio, therefore this one is neither. Lastly, 3.1, 4.7, 6.3, 7.9. This is looking arithmetic, but let's double check. So I'm going to take the first two terms, 4.7 minus 3.1, 1.6, and then let's take the last two terms, 7.9 minus 6.3, 1.6. It is arithmetic with a common difference of 1.6. Consider the sequence 3, negative 12x. Find the value of x for which the sequence is geometric. So it's telling us we want to make it geometric. So we're going to first divide the first two terms to see what the common ratio is and use that to figure out x. So I would do negative 12 divided by 3. So I know my common ratio needs to be negative 4. So we're multiplying negative 4 each time. So like 3 times negative 4 equals negative 12. That's how they got the second term. So now I just need to do negative 12 times negative 4 to get my next term, which is 48. So negative 12 times 4 equals 48. X equals 48. 15, a geometric sequence is shown. Use the explicit formula to find the 8th term. All right, so we need to first find the common ratio. So R equals, I'm going to do the first two terms, 8 divided by 2, 4. And then just to double check that I got the right answer, I'll take the last two terms, 128 divided by 32, 4. So R equals 4. Then we write the explicit formula, A sub n equals, first term is 2, so that's what we write first, times the common ratio 4 to the n minus 1 power. Now we want to find the 8th term, so plug in 8 for n, 2 times 4 to the 8 minus 1. Then first subtract your exponents, 8 minus 1 is 7, 4 to the 7th power. Remember, exponents first, then we multiply. And you can just type it all in your calculator at once. 2 times 4 to the 7th. And that's 32,768. A sub 8 equals 32,768. All right, that concludes this video. I will make another one for the next portion of the study guide, and I hope you tune into that. Thank you for watching.